This lesson has to do with the idea of variation, meaning that as something happens to one variable, something else happens to another variable. If I were to say that y varies directly with x, y varies directly with x, what I'm saying is that y could be the same thing as x, but usually not. It's the same thing by some sort of proportion. So what we can say is y is equal to some constant times x, and we say that where k is a constant. And what that means is that y over x is always equal to some constant, or x over y is equal to another constant. It means that as x increases, y also increases. And as x decreases, y also decreases. This is a type of variation called direct variation. And they can vary differently. Instead of just being a complete direct variation like this, what we can say is something like s varies directly with the square root of t. So that would be saying like s is equal to a constant times the square root of t. So varies directly with is a translation that goes to become equals k times something. It equals some constant times something. So why don't you try it with y is directly proportional, which is another way of saying varies directly. It's directly proportional to the cube of z. Well, if that's true, then y is equal to a constant times z cubed. That's the cube of z. We can also say something like u is directly proportional to the square root of v, which is another way of saying u is equal to some constant times the square root of v. So let's not forget that in each of these cases we have some constant k times it. So this can lead us to some things that we solve. And let's kind of set up a little bit of some problems we can do with this. So number one, suppose y varies directly with x. Then the problem can state if y is 24 when x is 8, find y when x is 2. So you got a few ways you can do this, but I want to look at the way that's going to be generalized to other types of variation instead of just varies directly. So we look at y varies directly with x. This means that y is equal to some constant times x. Then I'm going to take y equals 24 when x is equal to 8 and substitute that. If I solve, I get k is equal to 3, which means that now instead of y equals kx, I have y is equal to 3x. And then finally find y when x is 2. I would get y equals 3 times 2, or y equals 6. So let's look at another case. Hang on just a second. Let's say that we have a base jumper. Someone that just decides to skydive and jump off of things. So the base jumper, I know that if an object is falling towards Earth, the distance the jumper falls is directly proportional to the square of the time she is falling. The distance the jumper falls is directly proportional to the square of the time she is falling. If I let's let d equal distance, and we're going to let t equal time, and my units are going to be distance in feet and time in seconds. What I can say is d is equal to k, some constant, times the square of the time, t squared. So it says the distance the jumper falls is directly proportional to the square of the time she is falling. That's what this is. Now, given that, let's start with some more information. Let's say that the jumper falls 64 feet in 2 seconds. So that means 64 was equal to k times 2 squared, which would be 64 divided by 4, or k would be 16. So then I'm going to take that and re-put it back into the original and make it d is equal to 16 times t squared. Now I can answer some questions about this. We can, how far will person fall in 2.5 seconds? So if I do that, then d would be equal to 16 times 2.5 squared, which is the same thing as 16 times 5 halves squared, or 16 times 25 fourths, or 100 feet. So I could ask questions like, how long before she reaches, sorry, I can't write, she reaches 256 feet, which would be to take this equation right here and change that to 256 is equal to 16t squared. And I would get 16 is equal to t squared, or t is equal to positive 4 seconds, because negative 4 seconds just would not make sense. Okay, so that's direct variation. We also have something called inverse variation. And an inverse variation, as x goes up, y goes down. Things that we can say with inverse are things like y is inversely proportional to x. So what that means is y is equal to a constant times the reciprocal of x. Instead of kx, it's k times 1 over x, where we really say is y is equal to k over x. Another way to write that is xy is equal to a constant. And that means that as x goes up, y goes down in order to make sure that that maintains that constant. We're really going to use this one more than anything. So things that we can also say are things like s varies inversely with the square of t, which means that s is equal to k times 1 over t squared, or s is equal to k over t squared. I could say y is inversely proportional to x to the 4th. So that means y equals k divided by x to the 4th instead of times x to the 4th. That's what inversely proportional means. And I could finally say z varies inversely with the cubed root of t. And the cubed root of t. So that would be that z is equal to 1 over the cubed root of t. So let's do another example. If I say the volume of gas is inversely proportional to the pressure of gas on its container. So I have a balloon with some gas inside, and I have pressure working its way outside. And I'm going to let V equal volume. And we're going to do the volume in cubic feet. And we're going to let P equal the pressure. And the pressure is going to be pounds per square inch. So if I'm going to translate the statement, the volume of gas is inversely proportional to the pressure of gas, what I'm going to say is volume is equal to K divided by the pressure. That's what inversely proportional means. So I could ask the question, what pressure is needed to produce volume of 150 cubic feet if I know that a pressure of 48 pounds per square inch gives a volume of 50 cubic feet. So I'm going to take that V equals K over P equation, and I'm going to substitute what I know. I know that 48 pounds per square inch gives a volume of 50 cubic feet. So 50 cubic feet is the volume equals K divided by 48. And that means K is equal to 48 times 50. 48 times 50 is 2,400. So then my actual equation would be volume is equal to 2,400 divided by P. Now I'm going to take this thing, this 150 feet cubed, and plug that in so that I figure out the volume. Oh no, sorry, that's the volume itself. So it's saying what pressure would be needed. So I'm going to take that and plug it into the volume. 150 equals 2,400 divided by P. If I multiply both sides by P, I get 150P is equal to 2,400. Then divide both sides by 150, and I get 2,400 over 150, which is the same as 240 divided by 15. This is definitely going to divide because 240 is divisible by 3. I'm going to divide both by 3 and get 80 over 5, which is easier to divide. Then I get 16, and the pressure units are pounds per square inch. Okay, lastly, we have a style called joint variation. So we've had direct and indirect, and we have joint variation. And in joint variation, it's influenced by more than one variable. So I'm going to show you joint variation. Y varies jointly with x and z, which means y is equal to a constant times x and times z. So that's joint variation. I could also put something like z varies jointly with r and the square of s. So that would give me something like z is equal to k times r times s squared. You can also see something like v is directly proportional to t, something you might know from chemistry, and inversely proportional to p, which is another way of saying v is equal to k. Direct is times t, indirect is divided by p. And then you can also see f varies jointly with m1 and m2, and inversely with the square of r. So if f varies jointly, f is equal to a constant times m1 times m2, but then inversely is divided by the square of r, would be r squared. So let's do another example. Let's say, suppose y varies jointly with x and the square of z. If y is 81 when x is 2 and z is 9, find y when x is 4 and z is 4. So first step, y varies jointly with x and the square of z means to say y equals k times x and then times z squared. Next step is to take the second sentence and substitute that. So y is 81, k times x is 2, and z is 9. That would give me 81 is equal to k times 2 times 81, or 1 is equal to 2k, or k is equal to a half, which means that my actual form of the equation would be y is equal to 1/2 x z squared. Then find y. Finally, we're going to find y when z is 4 and x is 4. So y is equal to 1/2 times 4 squared. And that gives me y is equal to 32. Okay, last problem. Number 5. In electricity, the resistance, which we're going to call capital R, of a cable is directly proportional to its length and inversely proportional to the square of its diameter. Which we're going to define as a lowercase d. If a 300-foot cable that is 0.25 inches in diameter has a resistance of 0.2 ohms. What is resistance of a cable? Oh, sorry, I'm messing up my numbers here. Let's do a 100-foot cable has a that is 0.5 in diameter, has a resistance of 0.2 ohms. We're asking, what is the resistance of a 300-foot cable? that is 0.25 inches in diameter. I'm just going to put inches diameter. And let's move that over. Okay, promise this is the last bit of big writing you have to do. I know. I should have made a worksheet, but I didn't. So we get resistance is directly proportional to the length, which I'm going to define as L, so we can do that there. KL, and inversely proportional divided by the square of its diameter, d squared. And then I'm going to use the information it gives me. 0.2 ohm resistance equals K times 100 foot length divided by 0.5 squared for diameter. So 0.2 is equal to 100K over 0.5 squared is 0.25. And 100 divided by 0.25, if I multiply the top and bottom by 4, I get 400K. And so I get K is equal to, well, I have 0.2 divided by 400, which is 2 over 4,000, or 1 over 2,000. Or if you prefer a decimal, it is 0.0005. So that means I know that R is equal to 0.0005 times L over D squared. And then I'm going to go back up and see what the problem wanted. 300-foot cable, 0.25 in diameter. So 0.0005 times 300 over 0.25 squared. So if it's 0.25 squared, that is, I'm actually going to do this with fractions, so I'm going to go back to the fraction form. 1 over 2,000 times 300 over 0.25 squared is 1/16, which means I have 3 over 20 times 16. 3 over 20 times 16 is 3 times 4 over 5, so that is 3 times 4 is 12/5, which is going to be 2.4 ohms. And again, you guys will have a calculator. Okay, I think we're done.